Thanks very much. So today it's just Sam and myself who are presenting, and we're talking about how you go from a Shiny app that can be used for describing and exploring data through to reproducible and a production deliverable. So imagine the case that you've got a little Shiny app that produces some content. Here we're just looking at a very simple table, summary table. Imagine that this app is being used in discussions with your clinical team to explore data, to see what happens and what distributions of things are happening. But the key point here is that having come across a table here that's of interest, maybe now we want to get that table into our deliverable that we can share more widely in our organizations. So the question is, how do you do that? Okay, so take a moment. How would you get that table out of your Shiny app and into the hands of clinical teams for their review purposes? If you said that you want to copy it to the clipboard and then paste it into a Word document, as Liam Neeson's character in Taken would say, I will find you and I will kill you. Really, though, the question is, we've got this code, we've got this Shiny app. There's another angle to this that says, if I'm going to create some production deliverable or a table in a production deliverable, there's likely some process within your organization about how to code that up, how to QC it, and what kind of processes it all needs to go through before it goes out wider and gets disseminated through the organization. And when we were starting to think about the use of Shiny apps for this purpose of data exploration, one of the questions that came up was, well, how do you validate a Shiny app? And to be honest, the answer to that is it's harder than you think, okay? One of the things that we thought about in wrestling with this problem was, do we need to validate all of our Shiny apps? Or are there certain conditions under which we can allow non-programmers, so statisticians, or sorry, when I say non-programmers, I'm meaning people whose primary job role isn't programmer, to create Shiny apps, to use them in discussions with their teams. And so we came across these different, we kind of decided on these different layers or different levels of definitions of use. The first of these is what we were calling supervised apps. So in this case, the Shiny developer sits with the team and drives the Shiny app, if you like. So you can be sure that that Shiny app then will be used only within the scope of use that the developer has intended. The developer will know which bits are robust and work well, but also can steer the team away from areas that perhaps the app isn't intended for, or can advise on those things. Now, in that case, what we're saying is that these are low-risk apps. We might not even bother to validate these. And in business process terms, we come up with some good advice or some good practices for people developing Shiny apps for this purpose. The next layer up is what we were calling unsupervised. So this is the concept that you maybe take your Shiny app and you publish it to RStudio Connect, and then you're leaving that there for your colleagues to come along and perhaps upload some data into that app to use that app. Those are potentially higher risk, right? Because the developer is not available to comment, to guide, to provide assistance to people using that app. So then your app needs to be better documented. It probably needs additional help files or tooltips or pieces of advice within that app that give feedback to the user as it's being used. And one of the general pieces of advice that we had to give to our colleagues is Shiny apps and the validation of that Shiny app is actually a lot easier if you base that app on functions. So instead of 1,000 lines of server code, if your server code calls functions, then outside the Shiny app, you can go through the usual process of documenting and testing those functions, essentially creating something like a package, okay? The final level of scope of use was what we're calling anything that would be critical for patient safety or regulatory submission, or where that app is being used outside of the company. And in that case, you give it the full validation. So of all the code, of the UI, of all aspects of this, and you do the full process of documenting and testing and making sure that that app does exactly what it's intended to do, and that you can demonstrate that time and time again. Okay. Now, here's the other thing. It's really hard to retrofit reproducibility to your Shiny app if you haven't baked it in from the beginning. So if you've got 1,000 or 3,000 lines of server app code, it's going to be hard to then unpick all of that and demonstrate that the parts in it are reproducible and do exactly what you intend them to. So again, from the good practices perspective, what we were recommending to colleagues is to bake in the concept of reproducibility from the very, very beginning. Another aspect when you're publishing to Connect is that Connect environment exactly like your production environment? And we've heard about SCEs earlier today. As you deploy and publish your Shiny app to Connect, it's going to pick up packages and package versions in the place that you developed that. And then it's going to create a little self-contained world within Connect with the packages and versions that it's needed to run your app. And if those packages and package versions are slightly different to what you have on your production environment, then it's harder to guarantee that you'll get exactly equivalent results across both environments. So to come back to our Shiny app that we showed in the first place, one of the challenges we have is not just reproducing that table, but capturing the user choices and selections and the reactive values that sit behind that table, right? Because you want to be able to replay and pass those values into the functions so that you can recreate that table. Ideally, you also want to be able to load those values back into the app so that you can kind of show within the app not just reproducibility outside, but when you pull those values back in, you should get a consistent display within the app. And so over the next few slides, Sam is going to walk you through how we did that and how we get to our final solution to this problem.
Thanks, Mike. Next slide, please. Okay, so here you'll see a toy application that we created for this presentation. We're going to run that application here. And it's a simple GT summary toy app. We're going to scroll down and select the variables of interest. We'll click on those. And then we're going to select our grouping variable of interest, which will be the treatment arm. And then you'll see on the right-hand side, the table will be auto-generated. We're going to go into our metadata and enter in some table information like a table name, subtitle, and footnote. Then we're going to scroll up here in this application and we'll look at our tabs, and we have a capture panel tab. Here we can actually save the inputs and the exports that we're generating in the process of using this application into files. And you'll see that in our file system here. So we're going to get out of the application and go into our folder structure. And then you'll see folders that have already been created for inputs, which will be an inputs YAML file and an exports file as well. And that exports file is an RDS file. Okay, so let's go into some more detail of what we just did there. Next slide, please.
Sorry, Sam.
Okay, so one core principle here is that we are using our functions for the Shiny app. It's relatively simple, and we think this was best illustrated in a previous ShinyConf talk that Tanho did, where he emphasizes this principle of moving your logic that doesn't need Shiny to functions. So what's nice about that approach is we can use those functions within our scripts or within our Shiny app code. Effectively, the Shiny app has become a user interface for those R functions. We can demonstrate that these functions used external to the Shiny app produce exactly the same content that we used within the Shiny app. They can also be used to build a library of useful functionality within an R package. They can be QC'd and verified upstream of the use in a specific protocol or use case. Each function additionally can have accompanying Oxygen 2 documentation and a test that unit test. We can use those unit tests to confirm and ensure the code features are working exactly as intended. The other key part is that we externalize those user inputs, and we did that by saving it into a YAML file. So we wrote that into a file. Those inputs can then be used in a template script, and they can also be used to reconstitute the application state. And this can be done within the Shiny app, but it can also be done external to the Shiny app within this template script. So this is slightly different from, this is similar, but different from Shiny bookmarking, but it's something that you may have already seen. This YAML format is useful because it's easy to read and write in R, and it's easy to track changes in a version control system. Next slide. We're also capturing the exports, and what I mean by this is something that we use in the Shiny Test 2 package. But specifically, we're trying to capture those reactives that might be core to reproducing the content. So it serves as a key for comparison. They can be tables, figures, etc., any other objects that we're creating in the process of using the Shiny application that are of interest to us. And we're saving them in an RDS file. So that RDS file is basically a list of those objects together. They can be exported out individually. Similar to Shiny Test 2, we can specify those reactives that we're interested in, or we can do it more generally and try to export all the reactives that are created in the process of using a Shiny application. Then we can use those files, those objects that we created, to basically reproduce the output. So we're using those same functions that we used in Shiny to get that production output. We're using those YAML parameters as those inputs. And then this is nice because it's easy to QC and check to confirm that we're getting the exact same results. It doesn't depend on Shiny, Posit, or RStudio Connect, and it can be run in batch on our high-performance compute platform if we need to. Here's an example of this template script. So let's just go over one simple example that we created for the sake of this presentation. So you click Next, and first we're going to import in our files. And those are those R scripts that we actually use for our Shiny application. And we have a precursor in those file names called FCT, and it could be whatever precursor you want or kind of naming scheme you want to use to import your files. So then we're going to import those and also import in our inputs and exports files that we previously created in using the Shiny application. And then we're going to use those functions in sequence to basically recreate the output. And we can actually save that as an object within this template script. Lastly, we're going to use the Waldo package to do a comparison of those two different objects to ensure that we're getting the same results. Next slide. So what does a preferred production environment look like at Pfizer? So for us, with the key characteristics that we want to make sure we maintain are having a version control repository system. So this could be Get or an equivalent type of system. We want to make sure we have security built in and an audit trail that tracks who had access to what piece of content, what time. We want to make sure we have access within our production environment to a high performance compute infrastructure. So that could be a group grade or Slurm for production runs. And then we want to make sure we have access to project metadata and audit trail information. This is useful for QC reporting, which I'll go over slightly in the next slide. And then we have automation built in. And what that means is we have an automation step that we can run in our production environment to create a basic recipe that includes that content that I went over in the template script. This recipe can basically be used to generate a comparison. So what does a QC report look like? So this is an example that we created using R Markdown. It has a lot of useful fields, such as the location of files, the outputs, the input YAML file, the template script as well. And if you go to the next slide, you'll actually see a comparison of the output. So the output generated from the Shiny application compared to the output generated in our production system. So we can actually visually compare and ensure that it's generating the expected output. And next, we also have session information just to ensure we have tracking built in on what system those run on. Next slide. So in reflection, what are some of the key benefits of this approach? Well, as Mike mentioned, Shiny can be used as a part of the team discussion to derive, review, and refine the output specifications in real time. So this cuts down on the time between specification and final output. We can snapshot those things that we see in Shiny exploration and reproduce that in the long term. This also shifts some of the QC upstream to reviewing functions and functionality. We can use test that to demonstrate that code is working as expected and failing gracefully. And we can use Waldo to ensure the output matches exactly what is seen in the application. This app leans on functions, which have already been tested and proven, so we can reuse those functions in future applications. So this makes app development simpler and easier to QC. Automation is also built in. So we have integration with our production environment, and that has enormous benefits. This enables long-term reproducibility within our production environment. All right, thank you for listening.
Thanks very much.